Schönen Tag. We will together run CWatM for a longer time period, take the opportunity to visualize some of the outputs with a notebook. Let us begin by installing two packages. I go to my search and I type cmd. Right, we're going to first install Notebook. There is also Jupyter Lab, but I prefer still to use Jupyter Notebooks. Here's pip install Notebook. Pip install space Notebook. Now I already have this, so I'm just updating this. Yours will look a little bit different, but hopefully successful. We'll install one more package called Plotly, which allows for interactive figures. Pip install Plotly. Pip install Plotly. Again, I have just downloaded this, so it's just updating for yours, hopefully successful as well. Close out of this. Yours might take a little bit longer. And I go to where CWatM is within my computer. So that's C drive, GitHub, CWatM. We'll go to tutorial again. And now let us go to exercise 6. Okay. In exercise 6 right away, we will either play with the executable CWatM if we're using executable CWatM, or if we're using CWatM directly with Python, we can use the second executable. For now, I'll just run this. So I'm going to double click on play _ exe _ Rhine 30 minute _ Watercycles. We're going to run for 1 year spin up, and then 1 year where we produce model outputs. So right now we see it's going from 1999 to the end of 2001. The first year didn't produce any outputs, it just warmed up the model, and the second year is producing outputs. Okay, we go to settings. Scroll down. In fact, we see that it runs for a 2-year period. So step start is when the model starts to run. This is the first day of January of 1999. Spin up is when it starts to produce model output. So from the 1st of January, the year 2000. The model will end the end of January 2001. So we see the model has finished running for, I guess, these 3 years, 2 years producing output. Okay. I close out of this. Sometimes it works if people double click on this. What happens if I double click on this? Nothing happens. Alright, what we're going to want to do is open up a command prompt. cmd in the address bar. Great. Now we want to type in the command Jupyter, G-U-P-Y-T-E-R space notebook, N-O-T-E-B-O-O-K. Enter. This will open up a browser. Sometimes the browser will open up to a page that doesn't access anything. In this case, we have different URLs we can use here. For example, we can copy this in, do that, come back here, type this in the address bar, and it will open up a page similar to what opened automatically. Sometimes it opens automatically, sometimes perhaps not. Okay, we're going to open up the notebook called Watercycles. And we've just run CWatM for the 2 years to produce output in the output folder. All we need to do now is run with this fast forward button. It says restart the kernel, then rerun the whole notebook. All that matters is we just want to click the fast forward button. This will come up, and then we click restart and run all cells. Again, click the double arrow button and restart. No module named Pandas. Alright, let us install Pandas. Let's open up another command prompt. Okay, pip install pandas. Let me just confirm this is the command for pandas. Pip python pandas. I'm going to search this. Oh, great. So just pip install pandas. Copy this, but I have it here. All right. So pip install pandas, enter. Okay. Let's rerun this. Restart and run all cells. Double arrow button. Ah, great. Okay, so the first thing we see is this map. We're zoomed in just at the outlet point of our Rhine Basin map. We're still using the Rhine Basin as the example. So let's zoom out. This is called a density map. This is showing the main lines of discharge along the Rhine Basin. We're working at 30-minute arc resolution or 50-kilometer resolution. So each cell represents 50 kilometers. These maps will become clearer, finer as we move towards higher resolution. But here we see the main river of the Rhine Basin. Zoom out. This first map is showing evapotranspiration. So here we see evapotranspiration in the Rhine Basin is focused more towards the south of the basin. Zooming out just by using my mouse. No module named matplotlib. Great. Let's open up a command prompt. I have this one open. And let us install matplotlib. Again, just to confirm, python pip matplotlib. Okay. Pip install matplotlib. I copy this, minimize this, right-click to paste. Back here, and let us rerun. Double arrow, restart and run all cells. Okay, you see the two maps are being made. Okay, great. So we were running for 2 years. This is the main water cycle over 2 years. So we see of all the inputs into our basin over the 2 years, 91% was rain, about 9% was snow. Of outputs from the basin, of all the inputs, around 50% left through the outlet of the basin. That is just looking at the map. 50% of all the water, of all the rain and snow that fell over this region, left this point, left the basin through the river. See, about 50% of outputs is evapotranspiration. That's water that leaves through plants or through the soil. I will go into this more detail, but evapotranspiration is split up in the model between transpiration, the water that is used directly through the crops, leaves through the crops. Intercept evaporation, this is the water that lands on vegetation, leaves for example, and evaporates before touching the soil. So is intercepted before touching the soil and then evaporates. Bare soil evaporation is the water that evaporates directly from the soil. In this model, it works a little bit differently. This is also the first water used by plants. These details we can discuss much later. Snow evaporation, and then open water evaporation. Open water evaporation in the model context is water that comes from flooded fields, from urban centers, and the precipitation on top of lakes and channels and reservoirs. Again, we'll go through this in more detail, but this is just to show, to make sure we're visualizing some of the outputs. to scroll down just to show a time series of the graphic we're just looking at. So we see we had the inputs and the outputs. The inputs being rain and snow, the outputs being mainly river discharge and evapotranspiration. We see that the inputs are punctuated and sharp throughout the 2 years. So again, this is from the beginning of January to the end of January. So we see the inputs are punctuated sharp events throughout the 2 years, while the outputs are a dampened, smooth version of the inputs. This is quite characteristic of all basins, the water cycle of basins, that the inputs sharp and punctuated, the outputs smooth and dampened. If we're just interested in looking at rain and snow, by double-clicking on one of these, we isolate it. So this is rain throughout the 2 years. This is snow throughout the 2 years. We see snow here is, see the snow is mainly focused here. But in this basin, we see predominantly rainfall. All right. We have run the model for 2 years. We have visualized some of the outputs with the Jupyter Notebook. That's all for now. Cheers.